Enumerating Windows operating systems. It is important to note that even though many of the enumeration hacking tools presented are command prompt based, this does not limit their effectiveness. In fact, many enumeration techniques for older Windows OSs still work with newer versions because Windows still uses the same Active Directory networking system as well as the same TCP/IP protocol since the 1960s when it was first developed. Therefore, this is something to consider when planning for security on Windows systems. NetBIOS Basics. Network Basic Input-Output System, or NetBIOS, is a programming interface that allows computer communication over a LAN and is used to share files and printers. NetBIOS requires the server message block or SMB format to operate. NetBIOS names are computer names on Windows systems but have a limit of 16 characters. The last character identifies the type of service running, and each name must be unique on a network. FYI, Windows 95-98 used the protocol NetBEUI to communicate with peer computers before introducing TCP/IP, and therefore NetBIOS, as the default protocol because NetBEUI is non-routable, which means that it cannot use more than one network. NetBIOS null sessions. A null session is an unauthenticated connection to a Windows computer that does not use logon and password values. It has been around for over a decade and is still present on Windows XP. However, it was disabled by default in Windows Server 2003 and is not available in subsequent Windows operating systems. NetBIOS enumeration tools. The NBTstat command is a powerful enumeration tool that is included with Windows that displays the NetBIOS table. The NetView command shows shared resources on a network host. The NetUse command connects a computer with shared files or folders. Additional enumeration tools. Additional enumeration tools include Windows tools, including with Backtrack, which uses the SMB4K tool, DumpSec, Hyena, and Nessus and OpenVAS. DumpSec. DumpSec is an enumeration tool for Windows systems that allows a user to connect to a server and dump security permissions for shares, printers, and for the registry, as well as the ability to dump users, policies, rights, and services. Hyena. Hyena is an excellent GUI product for managing and securing Windows OSs. It shows shares and user logon names for Windows servers and domain controllers. Hyena also displays a graphical representation of Microsoft Terminal services, now called Remote Desktop Services since Windows Server 2008 R2, Microsoft Windows Networks, Web Client Networks, as well as find users and/or groups. Nessus and OpenVAS. OpenVAS operates in client-server mode. It is the open-source descendant of Nessus and is a popular tool for identifying vulnerabilities. The latest version of Nessus Server and Client can run on Windows, Mac OS X, FreeBSD, and most Linux distributions. It is handy when enumerating different OSs on a large network when there are many servers in different locations. Understanding cryptography basics. Cryptography is the process of converting plain text into ciphertext. Plain text is readable text, while ciphertext is unreadable or encrypted text. Cryptography is used to hide information from unauthorized users. Decryption is the process of converting ciphertext back to plain text. Understanding symmetric and asymmetric algorithms. An encryption algorithm is a mathematical function or program that works with a key. The algorithm's strength and key secrecy determines security. A key is the sequence of random bits generated from a range of allowable values called a key space. The larger the key space, the more random sequenced keys that can be created, and the more random keys that can be created, the more difficulty it is to guess the key. Symmetric algorithms. One key encrypts and decrypts data in symmetric algorithms. Advantages of this are that it is faster and difficult to break if a large key size is used. Only one key is needed to encrypt and decrypt data. Disadvantages include being challenging for key management and difficult to deliver keys without the risk of theft. It also does not support authenticity and non-repudiation. Symmetric algorithms continued. Types of symmetric algorithms include stream ciphers and block ciphers. Stream ciphers operate on plain text one bit at a time, while block ciphers operate on blocks of plain text. Data Encryption Standard. The National Institute of Standards and Technology, NIST, wanted a means of protecting sensitive but unclassified data, so they invited vendors in early 1970 to submit data encryption algorithms. IBM proposed Lucifer, a 128-bit encryption algorithm. However, the National Security Agency reduced the key size to 64 bits and then created Data Encryption Algorithm, or DES. Data Encryption Standard continued. In 1988, the NSA thought the standard was at risk to be broken based on longevity and increasing power of computers. In 1998, a computer system was designed to break the encryption key in only 3 days. Triple DES. The Triple Data Encryption System, or 3DES, served as a quick fix for DES vulnerabilities. It was called 3DES because it performed the original DES computations 3 times with different keys, which made it that much stronger than DES. However, it takes much longer to encrypt and decrypt data than DES did. Asymmetric algorithms. Asymmetric algorithms use 2 mathematically related keys. Data is encrypted with one key and can only be decrypted with the other, also called the public key cryptography. The public key can be known by public, but the private key is a secret key only known to the owner. This provides messaging authenticity and non-repudiation. Authenticity validates the sender of the message, while non-repudiation means a user cannot deny sending a message. Asymmetric algorithms continued. Asymmetric algorithms work as follows. User A encrypts a message with the private key and then sends it to user B. User B then decrypts the message with user A's public key. If confidentiality is a major concern for user A, then user A encrypts a message with user B's public key and sends it to user B. User B then decrypts the message with his private key. RSA. RSA was the first algorithm used for both encryption and digital signing. It is based on the difficulty of factoring large numbers using a one-way function to generate a key. A mathematical formula is easy to compute in one direction. RSA is used by many browsers using secured sockets or SSL protocol.